Compressed symbology is a term that's used to describe a symbol that can be used for automatic identification that can be scaled up or down depending on the application. You can make it as large as 3 feet square, put it on the top of a box and read it from an airplane, or put it on the head of a pen or a microchip and read it through a magnifying glass or through a microscope. A matrix symbol does essentially the same thing as a barcode. It provides encoded information that a scanner and decoder can read and save a human the trouble of entering data.
The data matrix symbol is a machine-readable code designed to be applied directly onto product surfaces using safe permanent marking methods. The symbol itself consists of a checkerboard pattern that contains black and white squares that represents ones and zeros, which can be converted back to human-readable code. It differs from barcode in that you contain 100 times as much data in the same space as a barcode. It can be read omnidirectionally, it can be read from distance, and it can be made from as small as 4 micron square, a code that would need to be read with a microscope, to as large as a football field.
NASA began its development of direct part marking with compressed symbology during return to flight of Challenger. And during that process, we determined that we wanted to enhance our configuration management systems. One element of configuration management is the identification of parts and the ease with which a person can enter that data into a computer. We found in many cases people were still doing it manually. Some people were keying it in, and some people were using barcodes. But the mixture of these was error-prone. Barcoding eliminated quite a bit of that, yet not having a barcode on the part was still promoting manual data entry. We felt like if we could put a barcode on the part, that this would enhance our configuration management system. Barcodes are not scalable. They would not fit on our small parts. We had to find a symbol that would. Compressed symbology did that function, and that is why we developed compressed symbology for especially our small parts. Compressed symbology development encouraged us to find new methods for marking parts. Many of the old methods were manual and did not have the fidelity to mark small parts or make small marks. We developed new methods using lasers, dot peen, even chem etch, small mass, and many other methods that are now computer controlled to make very small, high-fidelity marks.
The data matrix symbol can be applied to parts using a wide range of different marking methods. We can use all of the existing barcode marking methods to apply the symbol, as well as a whole variety of direct part mark methods that have been developed recently. For instance, if I were to want to mark cloth, I could use direct printing. I could use fabric embroidery. If I wanted to mark parts used in a harsh environment, I could use raised or recessed marks like cast and forge or cast and mold. I can use laser engraving, dot peening, laser shot peening. Marks on glass can be made using laser-induced paper deposition and other methods. And surfaces can also be marked with inkjet machines on the fly.
The development of compressed symbology and direct part marking has taken about 10 years. In 1997, we decided to go ahead and transfer those technologies that the commercial sector could use to them. We developed a partnership with RVSI. They commercialized those technologies, and they are transferring those to the commercial sector now. NASA is using direct part marking and compressed symbology primarily in parts tracking and configuration management. This is similar to the way industry is using this NASA-developed technology to track parts. For example, in the computer industry, many of your chips, computer processors, are marked in many places using a compressed symbology for identification and to preclude counterfeiting. In automotive and many other similar industries, aircraft industries, many of your parts are being marked for parts tracking, for configuration control.
In the marketplace, the product is brought to the marker where the marking is applied. Immediately thereafter, a reader mounted with the marker decodes the mark, checks its mark quality, grades it if you will, indicates to the operator if the mark quality is degraded so that he can bring the machine down for maintenance. That's then moved on through the process where it's read with either over-the-belt fixed-stage readers or with a handheld reader in mobile applications. They're very simple to use, very much like a barcode reader. They're positioned over the mark, trigger's depressed, an audible signal comes back and a green light indicating the read was made, and the output is then sent to the host computer for processing.
This NASA technology took over 10 years to develop, but it's on the brink of affecting everyone's life. Barcodes affect our lives today. We see them in the grocery stores and so many other places. We touch them now. Compressed symbology will be in so many places that barcodes can't go. They will be on the parts in the cars that we drive, on the parts in the planes that we fly, and in so many other applications. They will touch everyone's life, everyone in the world.